This is the second demo of two, where I show you how you can do machine learning with Oracle Analytics Cloud and Big Data, Oracle Big Data Cloud. One of the challenges when we do machine learning is that we usually do not know beforehand what is the best parameters to use or what is the best algorithm to use based on the data I have and the goal I have with the machine learning exercise. So most cases, we actually need to test multiple versions. It could be different parameters, it could be different algorithms. As shown previously, it's quite easy to create a model in OAC. However, if we need to create multiple models and we want to compare those models against each other, it gets a little bit more cumbersome, or I need to do a lot of different steps in order to be able to do this. Now, one way to address this is I can use standard Python code, so I can code this. And this is something that is very common around data scientists, that we use code for this. It could be Python, or it could be Scala, or it could be R, or something else. Another thing is when I do this and I create multiple models, I usually need to have a lot of compute power. So in this case, the Oracle Big Data Cloud, which is a Spark environment, suits very well because I can easily scale up and scale down with additional nodes when needed. So in my case now, I have a cluster with 3 nodes of 6 OCPUs and 90 gigabytes of memory. When I log into the Big Data Cloud, this is the first screen I see where I have some summary about my environment. In this case, we're going to use a feature called notebooks. And notebooks is basically, it's a Zeppelin notebooks, and it's a way for me to write code in different types of languages. I'm going to use a predefined notebook, but of course I can also import notebooks that others has created, and I can also create a new notebook if needed. But for this demonstration, I already prepared a notebook with the necessary code needed to do this. A notebook has, as you can see, different multiple paragraphs, and each paragraph can be either text where we describe what we're seeing, or it can actually be code. And the code could be in Python or Scala or R or SQL or whatever other types of interrupters we have added to our Zeppelin environment. Now, when I start this, I need to make sure that I have the data available for me to use. So we're using PySpark, which means we are using Spark as the compute engine for doing this. So the first thing I need to do is to read the data into a Spark data frame. And you can think of a Spark data frame as a table. Very simple. I have columns and I have rows. And in this case, my source file is a CSV file that is stored on Oracle Cloud, Storage Cloud, so on Object Store. And I'm using a functionality of Oracle Big Data Cloud that is called the Big Data File System. That is something that is using a product called Alluxio that enables me to cache files and objects in memory. And it does that transparency against the calling object. So for Spark, from Spark's point of view, my files are on disk. However, by using Alluxio, it will be stored in memory. So the first time I touch a file, it will read it up to memory. So the next time I need to touch that file, it's already in memory, so it gets faster. So I don't have to worry about eventually latency between the different types of storage types I use. Once I've read it into my data frame that I call the cust insure, I can also show the data here. So I can see that I have the same data I have in OAC. I have different types of columns and different types of values of it. I can also print the schema we are using for this. So I can do a quick check here to see, is the data types, are they correct to what I think they should be, that the numbers are numbers, and so on and so forth. In OAC, I could use the function called explain to get some statistics and information about my data. However, when I do this in Python or any other programming language, I need to do all the coding by myself. So in this case, I'm just going to stick to the standard statistics. So I can use a function of my Spark data frame that is called describe, and it will give me the count, the mean, the standard deviation, and the mean and max values of all the columns. And in the case where I have non-numeric values like profession, there's no mean value or standard deviation value for it, but it's a mean and max value, which means that the less used profession is accounted, and the most used profession is waiter waitress. So I have most of those. I can see for the sex or the gender that males are the one that I have most of, and female is a few. If I look at the numeric values, I can also see that there's a somewhat a rather big difference between all these values intervals I have. For example, has children, the mean is 0, the max is 1. Salary, I have the mean is 37,107 and the maximum is over 111,000. So there's huge difference between these values. That means in order for our model to perform, so it doesn't take forever to build it, we need to normalize the values so they are all using the same scale. And we're going to do that later on. We also need to manage our string values. This is something that was done automatically for us by OAC, all these transformations, but we need to do it by ourselves when we're using coding. So we start off by checking how many distinct values we have of each of these string values. I mean, if some one of these are almost one-to-one, we should probably consider to remove it like the customer ID. And we're not going to use the customer ID because we know that it is a one-to-one. But I do a count distinct here just to get a verification of that. So I can see I have 24 states, I have 100 professions, there's only 2 genders, we have 5 different marital status, and the LTV bin consists of 4 values, which is what I know it should be. So everything is fine here. So I can continue to do what we called a string index function. So what this is doing, and it does the same thing in OAC, but the only thing is it does this automatically for me, is it takes all these labels and create a index for it. So the indexes are starting from 0 to the number of labels. So in the state case, I will have 0 to 23. In the profession, I would 0 to 99, and for the sex or the gender, I will 0 to 1 because I only have 2 of those. It will put 0 on the label that has the most values on it. Now I can do this in multiple ways, but I'm using the built-in features of Spark, of the Spark ML library. So I'm using a function called string indexer, where we have an input column and an output column, and we apply this. And I'm using something that is called pipelines. Pipelines enables me to do things in, you could say, in batch. So I define how it's going to create the indexer. So I have one indexer for each and every columns, and then I run everything at one go by using this pipeline. And finally, I use select to see, well, how does this correspond? So for example, for the LTV bin, we have very high with the index 2, medium 1, high 0, and so on and so forth. So I can see now I have taken care of that. The second thing we need to do, and this is how machine learning in Spark currently work, is we need to have all the inputs vectorized and in one column. And I also, as we saw previously with the statistics, I need to normalize my data. So they have the same scale where every value is between -1 and 1, and the mean is 0. And also what is important when I do these things is I need to save these objects. So the indexer I created for creating index, I need to use that later on when I'm applying the data, applying the model to my new data. And the same thing with the vector assembler and the standard scaler, because I need to have them in the same area. And the scaling I'm doing need to be based on the same things, both for the training and the new data I'm using later on. Once I've done this, you can see I have 2 feature columns, one with the feature as it is, and one where I have scaled it. And then I also have one column for my LTV bin. Once this is done, we can now start train and evaluate our model. So we need to first split the data the same way we did in OSC. So I say I take 90% for training, 10% for validation. I'm using something, just a random split, so using random to it. I'm using a seed value here, and the seed value is just for reproducibility. So when I rerun the code, I'm going to get the same type of split. Now I can finally do my training. And for this example, we're going to use a classification called the multi-layer perception classifier, which is a feed-forward artificial neural network. This is the same algorithm that is used in OAC. The difference here is I have the possibility to build as many layers I want to do because I have control of the code. Now, as I mentioned in the beginning, the one challenge when we do machine learning is to decide what is the best parameters or the hyperparameters to use in order to get a model with the best result. Now, we can do this in different ways, and one way is to use something called cross-validation. And basically what cross-validation is that we split the data into different training and test data sets. For each training and test pair, we will iterate through the set of parameters, and for each parameter pair, we will train a model and evaluate its performance. Once we're done, we will select the model with the best performing set of parameters. Now, to code this, I mean, you need to do a lot of for loops and tests and everything. And the good thing is the Spark ML has a built-in function called cross-validator that can do this for us. So the first thing we do is we define what is the algorithm we're going to use. So in this case, we just going to use one algorithm. We could also use cross-validation to test different types of algorithms. In this case, we use one algorithm, which is the multi-layer perception classifier. We gonna hard code the layers, so I'm not gonna test with different types of layers, but I could do that. So we're gonna have 24, 24, and 4. So 24 is the input, so the number of columns I have in input. I have one hidden layer with 24 units, and the output is 4 because that is the number of different bins I have. The iterations we're going to do 200 iterations. We have a seed on this because so I can have the same result every time I run this. Then I set up my parameter maps. So I say, well, I'm going to have test different solvers. So in Spark, I can only use 2 different solvers or optimizer functions. So I cannot use the add-on function that was within OAC. Then I can test with different block size, which is the batch size we were talking about previously. So I can test, in this case, I test with 32, 64, 128. I can also use the learning rate or the tolerance and use different learning rate. That is how fast, well, not how fast it's going to learn, but it is how big steps it's going to take when it's trying to find the optimum values in this. So I can train with 3 difference. So that is 18 different parameter settings we can test from. So then I'm going to set up my cross validations to say, I'm going to use this model. I'm going to use this parameter grid. I'm going to use a multi-classification evaluator. So how do I evaluate my model? And then I'm going to use 3 folds. So in the end, we'll build 18 times 3 models. So 54 different models in one go is this. And this is what is done here. So when we run this code, it will go through and create all these 54 models, compare them, and return to us the model that performs best. I can then apply that on my test data, and I can see when I look at this that on an overall, it seems like it's doing quite well. The actual index, the predictions is good. And I can also create some metrics about this. So I can see the overall correct predictions is 99%. The 99% of all predicted values was correct. 99% of the existing values was correct predicted, and my overall accuracy is 99%. So this one was even doing even better than the model we did in OSC. So we see by using this cross-validation, we can even increase the accuracy of the model even better, even more. For my understanding, I can just print out what was the solver that the final model used. So they're using the LVFGs. The max iterations is 200. The block size is 64, and the tolerance or the learning rate is 1e up to minus 0.09. So it's 0.0000. You know, it's a very small learning rate. Now, I'm happy with this model, and I want to apply it to my new data. So I read up the new data. This is the same new data I have in OAC. I show the first 1K rows of this, and in this case, we don't have the LTV or LTV bin as we did in previously. Now, before we can apply this model, we need to transform the data the same way we did with the data we were using for training the model. And we also need to reduce the same objects that we did this for. So the indexers that I'm using here needs to be the same indexer that I used for my training data. Otherwise, it's going to be wrong. So I need to have that the state index 12 need to be WA. The bank teller needs to be the profession index 17, and it needs to be the same in both in the training and now the data I'm applying. After that, I need to vectorize it everything to put it in a one column. I also need to use the same scaler. So this is the scaler I created when I was training the model, and then I apply that to my new features for my new data, so they are used based on the same scale. This is something that is done automatically for me in OAC, but when I code, I need to do it by myself. So as a final step now, we can apply the model to our new data. We can also, before we show it, because as you remember, we had put the indexer on the bins. So what we're predicting is something between 0 and 3. So we can reverse that indexer back to the labels and convert it to that. So instead of a 0, we get a high, and we can show this data now. So now we have all the same data that we have before, but we also have the bin predicted bin value, high, medium, low, high, medium. And if I'm happy with this, I can save this as a new data set. I can use it in somewhere else. I can pick it up in OAC and do my reporting on it. So this was a quick way to show you how you can do machine learning with Oracle Big Data Cloud.